Hi, everybody. For today's lesson plan, we kind of went all over the place. So please just watch this whole video and watch carefully. If you were at school on Friday, your assignment was to finish a map coloring, mostly of the ocean floor, and then to answer these four questions on task 4 from the activity that we did that had David Hasselhoff at the beginning. So that was if you were in class. If you were not in class, you were asked to do task 4 on this. And in order to do that, you would go up to this website here, which had these slides on it, and you would look at this. So at the beginning of class today, we spent time looking at this map, which is basically the same thing you did if you were in class. Okay, so you either did the map coloring and the four questions, or you did task 4 and turned that in if you were in quarantine or at home. So what we started to talk about is what we saw in this map. And basically, if you look at this map, you'll notice that you have all the continents here in gray and all the colors that exist here. They're kind of color coded like we did on a map or like you looked at last Friday. And if you look at the red here, the red color down at the bottom represents 0 million years, and all the way to where the purple is and kind of the blue scope of things represents 280 million years. And if you look at the title, this says Age of Ocean Lithosphere, which basically just means age of the ocean floor. So if we look at this, we notice that first, the ocean floor is not the same age. You go to different places in the ocean, whether you go to the Atlantic or to the Pacific or to the Indian Ocean, and you see these different bands of color. And that means that what scientists went down to the bottom of the ocean floor and collected samples and brought them back up and analyzed their age, they found out that in all different places of the ocean, the floor was different ages. So for example, I think hopefully you can see this arrow here, but if you look in the middle of the Atlantic Ocean here, there's this deep dark black and red line here, and that represents really new ocean floor. And you did this if you colored in class too, but you'll notice that as I go further away from this black line, I get lighter and lighter and lighter. And in your example in class, you got a little darker, right? But I moved from the reds to the blues. So what's happening is that we have these areas all around the world that have these lines, these darkened lines that are on the map here. And it seems like where those lines are is where there's the youngest seafloor. And then as you go further out and out and out, so out into the edges, you get to more of the blue, green, and purple. So the edge of the seafloor is not the same. So if I asked you where's the youngest seafloor, you would say any part that on this map that's red, right? Or the lightest color if you did it in class. But it would be anything along this black line, right? So in the Atlantic Ocean, be straight down, kind of straight down the middle with a little bit of curve. In the Pacific Ocean, be over to the left, right? That big area of red. In the Indian Ocean, there's a whole bunch of different areas where the younger floor is. And then as you move away from those lines, it gets to more blues and greens and purple. So it gets older. If you were to look at where the oldest spots in the entire ocean were, you would notice that they're very close to where Asia is, the right off the northeast side of Asia, and they're pretty close to where the US is as well. So we have different ages of the seafloor all over the place, right? So something's going on at the bottom of the seafloor where there's younger seafloor at certain spots, and then as you move further away, it gets older and older and older. So scientists look at this a little bit more, and they came up with this idea that they think that the seafloor is actually spreading. So what's happening is that you have the youngest seafloor being made because things like material from the earth is being pushed out and into the ocean seafloor, and that forms a mountain or the youngest seafloor. And then as that happens, it pushes the older further and further and further back. So that's what's actually making the splitting up between the continents and the continental drift theory. Here's another picture. So again, heated material from inside the earth is pushing out and up. And so this layer that's right here by where the middle line and the opening is actually new seafloor coming in super hot and heated. It cools down, becomes part of the ocean floor. But because it's moving, it's pushing the older floor back and further back and further back to the edges. And so we have these areas where new seafloor is constantly being created. So I'll go back to this map where these red lines are, and then the older stuff gets pushed further and further away. Well, when the continents used to be all together as one in Pangea, right, they started where those lines were, and as the new seafloor was created, it pushed the continents away. So here's like a nice little picture of what shows. So think about as we show this Pangea and continental drift, think about what's happening in the ocean floor. That new ocean floor is pushing up and out and spreading out those continents, but happening very slowly over time. So here we go. They're still combined. So parts where you have the ocean moving the continents, right? Because new ocean floor is being made and pushing that sea floor away, which is separating and moving the continents. And so, very, very slowly, over hundreds of millions of years, this is what happened, starting at Pangea, going to the modern scape of the continents. Okay. But that's still kind of very tricky to understand. So, what we started talking about was what's really going on inside the earth and what's really happening in this underlayer here that's heated, what's really happening. So we started with a different activity and we talked about what the inside of the earth actually looks like. And you might have gone over this before in previous classes, but here's what we did. So what you want to do is go to Journey Inside the Earth. This first box here, you can just kind of skip past because I already wrote the ones for you. We did this in class, but you can just skip past this and look at this slide. So we talked about how there are 4 layers of the earth. The top part is called the crust, and it goes for about 18 miles down. So if I were to burrow down and make a hole about 18 miles down, that's how big the crust is. That's how long down and far it goes. It's really light and brittle. So brittle means it's going to crack and break easily. And that's what the crust looks like. The crust has the oceans on it. It has our land or continents on it. Underneath it, this orangey red level here is called the mantle. This is the thickest layer. It's about 1,800 miles down. So 1,800 miles down. So very big part of our Earth. And this is a little bit more flexible. This area flows a little bit more. And we'll talk a little bit more about why that happens. And then we have the outer core and the inner core. And the inner core is very dense, which means it's very hard. It is at the inner core, it is 13,000 degrees. Fahrenheit at the core, which is hotter than the intensity of the rays coming off of the sun. So this is what our Earth looks like. And you might ask, well, how do we know that? Because we can't go all the way down there. We've done many different studies and many different samples, as well as have kind of learned some things through understanding earthquakes and things like that. So this is what we understand of what the Earth looks like right now. So what you're going to do today is you're going to go to the next slide, slide 3, and you're going to click on this website. When you click on this website and go to it, you're going to see this. It's called Journey to the Center of the Earth. And basically what we're going to do is we're going to drill down the center of the Earth, all the way down to the center, and we're also going to go underwater. So we're going to see as we drill further and further down what happens. So as you can tell right now, just by going on this at 0.7 m, that's 7 meters, so a little bit less than a meter stick, rabbits and moles burrow, so they make a hole in the ground. At 1 meter, so a meter stick, a pig can sniff out truffles. So this is just how far we are down in the ground in the ocean. So what you're going to do is keep scrolling down this slowly, and as you're doing that, you're going to look at these questions and answer them. So for example, it says the M in the simulation stands for, so what I would do is put my cursor right where the line is and double click, and it stands for meters. So I'm going to write in meters, or as long as 1 meter stick. Okay, then I'm going to go on to the next one. How far do Olympic diving pools go? So now I'm going to look for that answer, and I'm going to go down. I don't see it yet. I don't see Olympic diving pools yet, so I'm going to keep going. And I can look at some of the information that as I go down. I'm going to keep going. Olympic diving pools. Here we go. Keep going. Here we go. Deepest swimming pool. So I'm at 42 meters. So 42 meter sticks. So then what I'm going to do is I'm going to go up. Oops, I'm sorry. Back to my screen and put 42 meters in. Or like I showed you before, just double click on the line and write, so it highlights, and then 42 meters. Okay, so you're going to do this whole sheet, all right, using that website. When you are done with that, you are going to read this page 4 and look at the pictures. You're going to read the rest of this page 5, and then you're going to try to draw a picture in this box. Drawing a picture is kind of tricky, so you are more than welcome to draw something on the side and insert it, Or if you would like to, use some of the drawing tools. If you click on this, Scribble is my favorite because Scribble allows you to draw things. You can also make text boxes. So insert a text box and add information as you're drawing about it. Okay? So when you're all done, you need to hand in this assignment for today. Okay, everybody, good luck. Have a great day.